Welcome to today's episode of Daily AI Brief, where we dive deep into the cutting edge developments reshaping the field of artificial intelligence. From revolutionary memory frameworks to the latest in dense models, we're exploring how these advancements could transform the way AI systems operate in real world applications. Plus, we'll discuss the future of AI sustainability and integration in different sectors. Stay tuned for a journey through tomorrow's technology today. Let's kick things off with an exciting development from Google Cloud AI Research, which has introduced ReasoningBank, a novel memory framework aimed at tackling AI's amnesia problem. This issue refers to AI agents' inability to recall and leverage past experiences effectively, leading to repeated errors and inefficiencies. ReasoningBank serves as a solution to these challenges by distilling reasoning strategies from both AI successes and failures. One of the noteworthy innovations in this system is the memory-aware test time scaling, which significantly boosts the learning capacity of AI agents by scaling their interactive experiences in meaningful ways. So how does ReasoningBank achieve these groundbreaking results? Here's a breakdown. The core of this framework includes ReasoningBank and MATS. Memory distribution. It distills strategies from past interactions, not just storing raw data, but organizing it methodically. The framework uses memory-aware mechanisms to maximize learning during interactions. Strategy retrieval. It enables high-level strategy retrieval to inform future decision-making, enhancing the agent's overall adaptability. What about performance metrics? According to evaluations, ReasoningBank has shown up to a 34.2% relative increase in effectiveness. Moreover, it has reduced interaction steps by 16% when tested on challenging benchmarks like web browsing and software engineering. However, it's not without its challenges. The generalization of ReasoningBank's success across diverse tasks remains largely untested. Scaling this framework to handle large applications with varied data types presents significant hurdles. Integration issues could also arise when aligning with current AI systems architectures. Interested in trying it out? Start by exploring their detailed paper on Arxiv, or delve into Google Cloud's blog post for a comprehensive overview. The implementation documentation can help you get started with crafting a memory bank. The takeaway here is clear. ReasoningBank represents a potential leap forward in creating more adaptive, efficient AI systems that are capable of self-improvement without the need for extensive retraining. As AI continues to evolve, such frameworks could become essential components of future intelligent systems. In the world of AI models, bigger isn't always better, especially if we're looking at how efficiently they perform. Alibaba's Qwen team has demonstrated this with their latest release, the Qwen 3.6-27B, a dense AI model that packs a punch with only 27 billion parameters, notably outperforming its predecessor, the gargantuan 397 billion parameter mixture of experts (MO) model, Qwen 3.5-397B A7B. The Qwen 3.627B has been making waves due to its impressive performance on several coding benchmarks, such as S2E-bench and Terminal Bench. The dense architecture focuses on delivering both robust and efficient solutions, which is a departure from the complexity of MoE models. Let's dive into the technical specifics. Dense architecture. With 27 billion parameters, it supports both thinking and non-thinking inference modes. This versatility allows the model to run diverse coding scenarios effectively while maintaining streamlined operations that do not compromise speed or efficiency. Training. Available in FP8 quantized versions, the model optimizes for resource efficiency without losing accuracy. This precision facilitates more responsive and adaptable coding tasks, a practical step for teams that demand quick iteration cycles. Open deployment. Qwen 3.6-27B is fully open source. Platforms such as GitHub, Hugging Face, and ModelScope provide developers with direct access, allowing customization and modification suitable for specific organizational needs. Fine-tuning. These are employed intensively to sharpen its capabilities specifically for coding tasks, allowing enterprises to tailor the model to fit their unique coding environments and requirements. In terms of performance metrics, Qwen 3.6-27B showcases significant improvements. Bench verified score. A 77.2 score, up from the 76.2 of Quen 3.5, reflects increased efficiency in handling verified coding problems. Terminal Bench 2.0, showing a score of 59.3 compared to 52.5 previously, indicating enhanced terminal task handling. With these advancements come some trade-offs. Dense models, despite their benefits, may not scale as efficiently for extremely large datasets as MOE models do. Additionally, while the model excels in coding specific tasks, its effectiveness in broader applications remains less tested. This points to a potential need for further development to assess resource demands. For those looking to engage hands-on, the model is accessible for deployment. You can clone it from GitHub or try deployments on platforms like Hugging Face. Detailed instructions are available in the official Quen documentation, making it easier for technical teams to integrate and test within their existing frameworks. In essence, Quen 3.627b marks a pivotal shift towards more streamlined and efficient coding models, setting a new benchmark for performance that doesn't rely solely on size, but instead leverages intelligent architectural design to deliver powerful and adaptable AI solutions for coding environments. Amazon's SageMaker AI has stepped up its game, introducing a new feature tailored specifically for the optimized deployment of generative AI models. Launched on April 21, 2026, this enhancement is designed to automate and streamline the intricate deployment process, eliminating the traditional need for manual optimization. This feature leverages automated recommendations that take into account different deployment configurations, all validated and tailored to user-defined performance goals. The end result? Simplified paths to effectively leverage the power of generative AI without the overhead traditionally associated with it. Here's a closer look at the technical details. Automated benchmarking. It uses NVIDIA AI Perf for benchmarking on real GPU infrastructure. This tool enables benchmarking across diverse models, ensuring that configurations are based on actual performance data rather than theoretical estimates. Resource optimization analyzes various instance types to determine optimal performances, adjusting based on user goals for cost, latency, or throughput. This involves selecting appropriate computing resources and fine-tuning parameters to match the specific needs of each application. Comprehensive metrics. Provided configurations include metrics such as time to first token, inter-token latency, and cost projections. These metrics offer insight into how quickly and cost-effectively the AI model can start generating outputs and the speed of output generation. Although no specific numbers are disclosed, Amazon claims that deployment times could be reduced significantly, with performance improvements like doubling throughput and up to 50% cost reductions. This positions SageMaker not just as a competitive tool in model deployment, but as an enabler of operational efficiency across industries. However, certain limitations must be considered. The effectiveness of these optimizations can differ based on specific use cases and AI model architectures. Additionally, the extent to which these improvements apply broadly across diverse scenarios remains to be fully validated. The one-size-fits-all approach may not suit every application, requiring developers to conduct careful evaluations. If you're eager to explore, the AWS documentation offers guidance on how to implement these recommendations. Watching related sessions like the AWS On-Air NY Summit can also provide practical insights into this topic, helping users understand how to navigate and take full advantage of these new features. In conclusion, the optimized inference recommendations do set a precedent for cost efficiency and performance in generative AI deployments, indicating a promising step forward in making such technologies more accessible and manageable for developers on the AWS platform. This advancement could very well become part of the evolving landscape of AI, as businesses seek to integrate sophisticated AI solutions more seamlessly into their operations. Setting a new standard in document parsing, Llama Index, in collaboration with Kaggle, has introduced ParseBench. Released just a few weeks ago, this open-source benchmark selectively gauges document parsing systems, honing in on their capacity to transform documents into actionable data via AI agents. Traditional OCR evaluations frequently overlook these agent-focused capabilities, but not anymore. Here's the inside scoop on how ParseBench operates. Component elements. Over 2,000 human-verified pages from diverse industries serve as the dataset backbone, comprehensive yet targeted. This diverse array, culled from sectors like insurance, finance, and government, ensures a well-rounded evaluation. Each page is meticulously scrutinized to set a consistent base, crucial for developing robust AI agents capable of handling real-world variability. Evaluation rules. Employing over 167,000 deterministic test rules, ParseBench focuses on 5 key dimensions: tables, charts, content truthiness, semantic formatting, and visual alignment. These aspects are meticulously chosen to evaluate both the accuracy and applicability of parsing systems beyond mere text extraction, ensuring documents are translated into usable forms for AI agent deployment. Agent-centric focus. Designed with AI agents in mind, this benchmark prioritizes the practical utility over just maintaining visual fidelity of text. ParseBench aims to enable autonomous decision-making, pushing document parsing capabilities towards understanding and context rather than superficial resemblance. This approach aligns with the increasing demand for AI systems to function autonomously in enterprise environments. Numbers in perspective. Bringing numbers into perspective. These include approximately 2,000 pages undergoing stringent evaluation procedures against determinate test rules crafted specifically for this benchmark. Such extensive testing ensures that AI systems are not only accurate but also reliable in operational contexts. Challenges and future exploration. Navigating its challenges, ParseBench hasn't fully fleshed out specific performance scores for benchmarked systems, potentially complicating tool comparisons. Additionally, its broader adoption and real-world applicability in AI practices warrant future exploration. As this benchmark matures, it may reveal new performance gaps, leading to potential iterative improvements in parsing tools. Practical steps. Aspiring users should reference GitHub for implementation details and study-related publications to stay ahead of developments in the document parsing field. Engaging with this benchmark offers developers an invaluable resource for refining systems, while enterprises can benefit from choosing tools that best suit their operational needs. Ultimately, ParseBench delivers a fresh perspective in evaluating document parsing systems, shifting the focus towards empowering AI agents with better contextual understanding for autonomous decision-making. In the realm of AI-powered music creation, the new release from Suno, version 5.5, is causing quite a stir. Among its many enhancements, the platform introduces features that bring a full suite of creativity tools directly to users, offering new possibilities for musicians and producers alike. At the heart of Suno v5.5 is its voice cloning technology, delivering custom vocal models that afford users unprecedented control over the music production process. This technology operates with a reported 80% accuracy, allowing users to create lifelike vocal representations of any voice they wish to model. Such a level of precision is achieved through sophisticated machine learning frameworks, which have been refined to maintain vocal naturalness and clarity. As a task that could ordinarily take audio engineers hours, achieving this feat in minutes on Suno demonstrates a remarkable technical advance. Voice cloning isn't the only standout feature. Suno's My Taste feature, an innovative personalization tool, utilizes an algorithm to adapt and generate music based on individual user preferences. This feature represents a leap towards truly democratizing music creation, empowering users of any background or skill level to craft music that feels deeply personal and unique. From an economic perspective, Suno v5.5 is set to attract diverse users with its subscription models. The platform's tiers, priced at $10 a month for Pro and $30 a month for Premier, make it accessible compared to hiring professional studio services, which can cost hundreds or thousands of dollars. With these affordable options, Suno broadens access to professional-grade music production tools. Another feature enhancing the production workflow is the stem export functionality, boasting an impressive speed of approximately 45 seconds per song. This feature allows users to manage and manipulate individual components of their tracks quickly, fostering higher efficiency in the music editing and mixing processes. However, while the potential is extraordinary, there are trade-offs. Some users report variability in the success of voice cloning owing to individual voice characteristics. This can lead to dissatisfaction if results do not meet expectations. Additionally, there are occasional reports of lag in customer support responses, which can be frustrating for users needing immediate assistance. For those intrigued, visiting Suno's official website will grant access to the latest version, while help documentation offers additional guidance on setting up and getting started. It's also worthwhile exploring user reviews on platforms like Trustpilot to gain insights into the practical experiences of others. In summary, Suno v5.5 represents a significant leap forward, providing music enthusiasts and professionals tools that were once confined to high-budget studio environments. The update pushes the boundaries of what AI and creative technology can achieve together, leading the charge in a new era of music creation. Xiaomi has recently expanded its AI catalog with the launch of the MiMo v2.5 Pro and MiMo v2.5 models. This development is part of their ambitious MiMo series and represents a leap in capabilities for agentic AI tasks across multiple modalities. The MiMo v2.5 Pro is particularly notable for its staggering computational power. With over 1 trillion parameters and a vast 1 million token context window, it offers a significant advancement in handling highly complex tasks such as natural language processing and intricate software engineering challenges. This large context window allows the model to maintain dialogue continuity and comprehend extended textual inputs without losing coherence, making it ideal for applications that require extensive contextual awareness, like continuous dialogue systems and technical documentation analysis. Technical drill down. Advanced neural processing units. These are specifically engineered to manage multimodal inputs, processing text, images, audio, and video concurrently. This multimodal flexibility is crucial for enterprises that rely on seamless integration of various data types, improving efficiency and reducing processing overhead. Transformer-based architecture. By employing a transformer framework, MiMo v2.5 Pro facilitates efficient management of complex tasks, ensuring rapid processing and precise outputs, even with the contextually demanding workloads. Transformer's parallel processing ability supports the model's scalability and performance under high-demand scenarios. Long-term planning. The integration with software engineering tools allows for enhanced task planning and execution. This capability is vital for companies using AI for project management, allowing them to streamline workflows and predict project outcomes more accurately. Cost efficiency. Xiaomi has strategically positioned these models with competitive API pricing, only $1 per million input tokens and $3 per million output tokens, considerably undercutting similar offerings like Claude Opus 4.6 and GPT 5.4. This cost advantage broadens accessibility, enabling smaller firms and startups to harness advanced AI without prohibitive upfront costs. It presents an opportunity for widespread adoption across various sectors, from finance to healthcare, where AI can drive significant value. Benchmark performance. In benchmark evaluations such as the SWE Bench Pro, the MiMo v2.5 Pro achieved a remarkable 57.2% pass rate, dramatically surpassing the average of 25%. This performance metric reflects its robust capability in handling sophisticated software engineering queries, showcasing potential applications in automation and code analysis. Future prospects and challenges. While the MiMo v2.5 series offers promising advancements, uncertainties remain around real-world performance validation and the timeline for the release of open-source variants. These elements are critical in securing developer trust and widespread adoption. Prospective users are encouraged to engage with the API for preliminary explorations and assess the model's responsiveness in practical scenarios through experiments with multimodal inputs. In conclusion, Xiaomi's MiMo v2.5 Pro represents a major step forward in making advanced AI functionalities accessible and cost-effective, potentially reshaping expectations in the AI industry. By pairing high performance with consumer-friendly pricing, Xiaomi is setting a new standard for efficiency and accessibility in AI technology, driving innovation and setting pressure on competitors to follow suit. EnterpriseDB (EDB) is pioneering a transformative shift in how energy efficiency is measured within AI environments. introducing the groundbreaking intelligence per watt standard. This initiative is crucial in addressing the ballooning energy use of AI technologies, steering the industry towards greater sustainability. Core implementation. The intelligence per watt standard is more than just a concept. It is a comprehensive strategy aimed at optimizing AI efficiency by rethinking both software and hardware aspects. At its core, it focuses on optimizing data layers critical for AI performance, which reduces the electrical energy required to process and analyze data. This dual approach ensures that AI technologies do not just perform better, but do so in an energy-efficient manner. Key metrics and advances. The intelligence per watt benchmark is a revolutionary metric set to evaluate AI systems based on their energy consumption per unit of intelligence, i.e., computational output. 2. Vector indexing enhancements. One of the significant technical breakthroughs achieved under this initiative is the advancement in vector indexing capabilities, now improved by 5x to 12x. This drastically reduces the computational time, lowering energy usage while maintaining speed and accuracy. 3. Token usage. Another critical metric is the reduction in token usage by up to 57%. Tokens are essential in machine learning models for tasks like natural language processing. Reducing them directly correlates to less energy required. Implementation and feasibility. To implement this standard, EDB leverages advanced algorithms designed to minimize energy consumption without compromising performance. The system is tailored to integrate smoothly with existing AI infrastructures, helping organizations transition without significant overhauls. Environmental impact and trade-offs. The potential environmental benefits are substantial, with estimations indicating up to an 87% reduction in data center emissions possible through this approach. However, realizations of these reductions in varied, real-world applications remain subject to further validation. Independent evaluations are necessary to substantiate these claims, particularly concerning third-party hardware and varied data center architectures. Future implications. If proven effective, this could set a new standard across the industry for AI sustainability, providing a model for others. This innovation could influence how AI infrastructure is developed, urging enterprises to adopt eco-friendly designs. Despite these promising projections, the scalability of intelligence per watt across diverse environments and existing infrastructures is still under scrutiny. The interplay between hardware capabilities and software enhancements will be a decisive factor in its widespread adoption. Hashtag. Moving forward, organizations interested in leveraging these advancements can explore the EDB PG AI platform, which offers tools and resources to integrate these efficiencies into their operations. Detailed metrics and case studies are available on EDB's Intelligence per Watt dedicated website, guiding entities through potential implementation strategies. Overall, EDB's introduction of the Intelligence per Watt standard is a significant step in redefining the landscape of AI development towards a sustainable future, balancing the demands of performance with the necessity of ecological responsibility. Artificial intelligence is revolutionizing facilities management, moving maintenance strategies beyond reactive frameworks to embrace proactive predictive analytics. This evolution is poised to not only heighten efficiency, but also support sustainability efforts across operational environments. Utilizing AI-driven insights, facilities management can anticipate equipment failures and resolve them before they translate into costly downtimes. The core of this transformation lies in the integration of IoT sensors with machine learning algorithms that continuously monitor and analyze equipment conditions. These sensors collect data on temperature, vibration, and other critical metrics, providing real-time feedback essential for predictive maintenance. Technical elements encompass real-time monitoring. By implementing IoT sensors, facility managers can continuously track equipment performance, allowing for immediate response to deviations from normal operating conditions. This approach ensures that facilities are never blindsided by unexpected failures. Pattern analysis. Machine learning models are deployed to scrutinize historical and current data, identifying patterns that suggest impending equipment issues. Techniques such as regression analysis and anomaly detection are pivotal in predicting failures with an expected accuracy of 85 to 90% by 2026. Optimized maintenance schedules. Leveraging predictive insights, maintenance interventions can be scheduled based on actual needs rather than predetermined intervals. This strategy not only reduces unnecessary upkeep efforts, but also helps in allocating resources more efficiently. The promise of these advancements comes with challenges. High upfront investments in AI systems can deter some organizations. Integration with existing legacy systems might complicate transitions, and issues surrounding data privacy in handling sensitive operational information pose significant concerns. Organizations keen on adopting AI-driven predictive maintenance should start by exploring integration options within their current systems. Examining available AI platforms tailored for predictive maintenance can illuminate effective paths forward. Conducting pilot implementations in smaller operational settings can also provide essential insights into the system's effectiveness and value. In conclusion, by integrating accurate predictive models, facilities management can significantly reduce downtime, lower maintenance costs, and extend asset lifespans. These benefits offer entities a competitive edge, aligning them with modern technology trends and contributing to a future where operational efficiency is at the helm of strategic goals. IBM's 2026 X-Force Threat Intelligence Index paints a stark picture of the cybersecurity risks engulfing the manufacturing sector. Accounting for 27.7% of cybersecurity breaches last year, manufacturing now stands as the primary industry targeted by cybercriminals, a title it has held for 5 consecutive years. The vulnerabilities in manufacturing stem largely from weaknesses in operational technology, systems, and the inherently interconnected nature of modern manufacturing processes. These vulnerabilities pose significant risks, especially when exploited by increasingly sophisticated cyber threats such as ransomware. Operational technology weaknesses. OT systems, which control the physical processes of manufacturing, are often less sophisticated in terms of cybersecurity than traditional IT systems. They frequently lack advanced security measures like encryption or multi-factor authentication, making them attractive targets for cybercriminals. These systems are designed for reliability and safety rather than security, creating gaps that hackers can exploit. This contrasts sharply with IT systems where security has become a central focus over the past decades. Entry points. The integration of IT and OT in manufacturing processes means more devices and systems are connected, increasing the attack surface. Products linked within manufacturing supply chains can serve as multiple access points for malicious actors. This large number of entry points is particularly concerning in sectors like automotive and consumer electronics, where the supply chain complexity amplifies risk exposure exponentially. AI utilization in threats. Cybercriminals are increasingly leveraging generative AI tools to enhance their capability to discover and exploit vulnerabilities rapidly. AI can automate the process of identifying weak spots in a system's defenses, and these tools can even generate highly sophisticated phishing schemes, making it easier for attackers to trick employees into compromising systems. Despite improvements in security protocols, the IBM report highlights a concerning 40% surge in incidents of vulnerability exploitation in 2025. Active ransomware operations have almost doubled in that time, which shows the scale and urgency of the threat. Addressing these issues requires a multifaceted approach. Manufacturers are encouraged to implement robust authentication controls, ensuring that only authorized personnel can access sensitive systems. Regularly patching outdated software and systems is also crucial to mitigate vulnerabilities as new threats emerge. Furthermore, integrating AI-driven security solutions can enhance threat detection capabilities, allowing for more responsive and effective defenses. IBM's insights underscore the urgent need for manufacturers to adopt comprehensive cybersecurity strategies tailored to protect both IT and OT environments. Aligning with industry-leading practices, manufacturers can stave off attack vectors and protect their operations from an ever-evolving cyber threat landscape. As artificial intelligence, AI, continues to integrate into diverse sectors, the call for the evolution of open-source principles in AI is growing louder. The introduction of the Open Source AI Definition, OSAD, by the Open Source Initiative, OSI, signifies an important step in refining these principles. OSAD emphasizes open implementation, open specification, and open governance in collaboration with major tech players like Mozilla Foundation, Wikimedia Foundation, Microsoft, Google, Amazon, and Meta. This collaborative effort seeks to promote transparency and build trust as AI becomes increasingly embedded in society. The framework outlined by OSAID responds proactively to concealment issues in AI technologies, thus enhancing accountability among developers and stakeholders. OSAID provides a structured approach to AI systems, defining principles that guide the assessment of open source AI. This includes fostering collaborative governance models, integrating contributions from diverse stakeholders, and proposing model evaluation standards that prioritize transparency and ethical considerations. To put numbers into perspective, by early 2026, investment in open source foundation models has exceeded $25 billion. Open source models have been implemented in approximately 40% of enterprise AI deployments. These figures underscore the increasing trust and reliance on open source solutions within the AI community. Developers and organizations can take practical steps by referring to the OSAID when benchmarking AI systems against open source principles. Engaging with platforms that promote open governance and exploring case studies that highlight successful OSAID implementations can provide valuable insights. However, challenges such as the free rider problem and the sustainability of long-term governance frameworks need to be addressed. Ensuring that open source AI remains vibrant and adaptable requires confronting these issues, alongside rigorous testing of governance models for effectiveness. This expansion of open source ideals is more than technical. It touches on market power, innovation potential, and democratizing technology access. With the rise of AI, transparency and ethical development become paramount, making such frameworks essential not just for today's applications, but also for shaping the AI landscape of the future. The adoption of these principles could lead to a significant shift in how AI technologies are governed, potentially democratizing access and fostering innovations that align with open source movements. In the evolving landscape of artificial intelligence in healthcare, much of what is touted as AI often lacks true integration into core workflows. Aditya Bansod's insightful commentary brings light to this critical issue, noting that many current AI implementations merely embellish existing systems without truly embedding into the day-to-day operations. By 2027, it is projected that organizations that manage to achieve genuine integration of AI into their workflows will significantly outperform those relying on traditional software-as-a-service SaaS models. Understanding the shortcomings. 1. Lack of deep integration. Most AI tools today do not seamlessly blend with existing healthcare workflows. This limitation restricts their potential benefits, ultimately resulting in negligible improvements in operational efficiencies. The key is to embed AI solutions not just as standalone units, but as part of an ecosystem that spans the entire workflow. 2. Contextual understanding. For AI to achieve optimal performance, it must interpret and act according to specific contexts, a process known as context engineering. This involves structuring accessible data that informs decision-making beyond mere task execution. Without this capability, AI systems remain largely ineffective in dynamic environments such as healthcare. 3. Adopt hybrid models. A hybrid approach that integrates both agentic AI, capable of independent, real-time decision-making, and structured contextual data is necessary. This combination enhances reliability as AI systems can respond to and learn from real-world complexities. Moving towards transformative improvements. Investing in AI systems that embed directly into relevant healthcare workflows can lead to significant operational transformation. These systems will need to transcend basic task execution by making informed, context-aware decisions. This requires advanced infrastructural support capable of handling real-time data processing and shared memory across systems. Technical, practical steps. 1. Evaluate current solutions. Healthcare organizations must rigorously evaluate their existing AI solutions for true integration depth. This means understanding how these tools interact with and enhance existing workflows rather than merely adding features that may not align with operational needs. 2. Pilot controlled implementations. To ensure a meaningful ROI, organizations are encouraged to conduct pilot projects in controlled settings. Such experiments help in understanding the real-world applicability and effectiveness of the AI tools, thus guiding further investment. 3. Implement context engineering. Adopting context engineering practices enables AI systems to perform with greater efficiency as they are informed by relevant, nuanced data. This is crucial for ensuring that AI decision-making aligns with the complexities of healthcare operations. Trade-offs and future outlook. Transitioning to integrated AI systems presents challenges, such as potential disruptions in existing workflows and governance issues that need careful management. Furthermore, the concept of context engineering, while promising, is not fully validated, posing an element of risk. However, overcoming these hurdles may pivot the AI focus towards seamless integration, ultimately leading to improvements in patient outcomes and operational efficiency. As healthcare organizations navigate these complexities, it is clear that those ready to embrace comprehensive, context-aware AI integration will be better positioned to harness its full potential by 2027. And that's a wrap for today's episode of Daily AI Brief. We've journeyed through memory innovations, explored the power of dense models, and considered the growing importance of sustainability in AI. As these technologies evolve, their impact will ripple across industries, opening new frontiers for innovation and efficiency. Keep learning and stay curious. Your AI journey is just beginning.